Welcome, everyone. Nice to see people coming back. Okay. As usual, we'll give people a few moments to come in and arrive and start up, and then we'll go over the homework problems, and then we will start talking about modules and packages and other such related things in Python. Hey, Raymond, welcome back. Okay. Whew. All right. Hope you guys have all been doing well. Hopefully, well, you know, it's now officially summer, so you can now, well, at least in the northern hemisphere, so you're now allowed to complain that it's hot. Ironically, I actually am staying indoors most of the time, so it's not that hot. But hey, that's the way it is. Okay, let's already start to dive in, and what we're going to do is go over the homework that I'd given last week, and we'll talk about functions a bit more, and then we're going to talk about modules, packages, and how they can help us. And obviously, if when you have questions, do not hesitate, not that you folks usually do hesitate, but don't hesitate to ask them in the chat. So I'm going to just move some windows around, and I'm going to start the screen share. Screen share on my desktop. Ba-bam. There we go. And I think I'm screen, oh, it's saving here. Very good. All right, do I have this here? Excellent, excellent. Here. All right, folks. So, oh, and there's already something in the chat. What do you know? Ready. Hello from Canada. Hello back to Canada. All right, so let's start off with the homework, as I said. Let me just copy and paste it, see what I can do with that. From there, let's make this into Markdown, paste it there, and then if I say 1, 2, 3, we'll split this, make that Markdown, split this, make it Markdown, and split, well, don't just split anymore, make it Darkdown. Okay, another hello from Canada. Excellent, excellent. Okay, so we're gonna start off with, we're gonna be writing functions, strangely enough. Write a function that takes a dict as an argument, and it returns a dict with the same keys, in which the values have all been doubled, unless someone passes a second optional argument factor, in which the values will be multiplied by the factor. So what I'm basically trying to do is say this. I want to say d equals a1, b2, c3. And I want to be able to say here, you know, oh, I guess I didn't say what I should call it. So let's call it, you know, multidict. Okay, that's sort of good, right? And I'll say d, and I'll say new d equals this. And I'll talk about whether we should mutate the data in a moment, because this actually came up in the forum where some people shared their suggestions and their answers. So, and the idea is that new d should be a2, b4, and c6. Or if I say new d equals multidict of d factor equals, let's say, 3, then new d should be a3, b6, c9. We're really, oh, hey there, Mike from Indiana. And here we're testing my math skills dramatically. So how's this going to work? I'm going to say here def multidict. And we know that we're going to take one argument. We know that we're going to take a dictionary argument. I should add here, and I've mentioned this a little bit in the past, do not use dict as the name of a variable and then include as a parameter. It is a super, super common thing for people to do. And Python's not going to complain per se, but you will run into trouble at some point. So I'm just going to call this, well, I don't want to call it D because I've already used D out there. I don't want to like make things complicated and so forth. So I'm going to call it the dict. Okay, not the most original, but fine, we'll deal with it. So now what do I want to do? We know that we want to create a dictionary. Well, we know that we want to return a dictionary. So I'm going to say here output equals a dictionary. I'm going to say return output. And then the question is, what do I do in the middle? Well, in the middle, I'm going to go over this dictionary. I'm going to say for key value in the dict dot items. And I'm now going to say output, the output dictionary key, equals value times, well, times what? Well, I could say times 2. But we said in the specification that we should also take an additional argument, an optional one, called factor. So I'm going to say here, factor equals 2. And when I do this, it means that the function, technically speaking, takes 2 arguments. It requires 2 arguments. But realistically, it only takes 1 because this second one here has a default value of 2. If we don't pass it, that variable factor, that parameter factor will have a value of 2. So I just say value times factor. And we know 100% that there will be a value in factor. We don't know if it's going to be 2 or something else. And sure enough, if I now say print new D, and then print new D, we're going to see that's A2, 4, and 6, and A3, 6, and 9. It worked. Huzzah! Now, I'll take questions in a moment. I mean, if you have questions, you could ask them, but it's really important here to point out something that people in the forum did, and some people did and some people didn't, and it's my mistake for not being more explicit. But there is another way to do this, and a slightly different way with big, big implications for how you do it. So what people did was they said, okay, I'm going to write this, and here's what I'm going to do. I'm going to return not this new dictionary, I'm going to return the dict, the same one as I got. And then here's what I'm going to do. I'm going to say for key value of the dict items, the dict key equals value times factor. Notice what we're doing here. Hey, Leon. What we're doing here is we are iterating over our dict. That hasn't changed. We are updating our dict. That has changed. Now we're changing our input dict, right? The argument. And so when we do this now, watch this. If I say now new D equals multi-dict of D, print new D, well, it's going to work. But look what happened to D, our original D. That has also changed. And the key thing here, or the key value thing here, it's the dictionary, right? The key thing here is that in this case, we are changing the dictionary that we were passed. So the user said here multi-dict of D. So that's like a reference, right? So D, the global variable, is referring to a dictionary. And then inside of the function, the dict is a local variable referring to the same function. Any changes to the local dict are going to be reflected in the global dict because they are the same. They're 2 aliases for one another. And so this has a big difference. This means this version of the function is actually going to change its inputs, whereas this version of the function is going to return a new input. Which is right? Well, that is the matter of a lot of debate between programmers, among programmers for decades, right? Which is the right way to do it? And Python actually is inconsistent on this front as well. Basically, the way that Python works most of the time is if you have a mutable data structure, like a list. So if you append to a list, that will actually change the list. And then actually, if you change the list, it's going to return none to dissuade you from using this return value. So if we were doing it like the Python way, we would say not return the dict, we would say return none, or just not even nothing, nothing at all. And then we would not be returning a new value, rather the original dictionary would be modified. And again, there's nothing wrong with that per se. My personal preference, as a general rule, is not to modify the original. My personal preference is if I can return a new data structure, I'd prefer to do that. Now that's very nice and easy for me to say, but sometimes you have no choice. For example, what if you're dealing with a really, really huge data structure that takes tons of memory? If you return a copy or a new version of it, that means it's going to take twice as much memory, and that might be too much for the system. And then there's also like, what are the standards on your team and how your software is working? How often do you want to be changing data? How often do you want to be updating data? How often do you want to be returning something new? So I'm not saying one is right or one is wrong. My personal preference is to generally return something new. But again, I didn't specify clearly enough. And this is, I can't stress enough how often this happens in the computer industry, right? Specifications are written. Everyone's like, yes, 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 we agree on how it should work. And then massive arguments result because the specification was unclear, it was ambiguous. This is where automated testing has begun to help out a lot. Because what happens then is if you can set some tests up and say, this is how it should work, then if something goes awry or if the software doesn't quite work, you go back to the test and say, oh, wait a second, you should have caught this. Or better yet, we can write a new test and then everyone will agree on in the future. Questions about this this function here? This is a fun one. And then we got 2 more to go through. I'll just take a sip of tea while see if there are any questions. All right. So if there are none, and again, they can keep coming later on, not a problem. So the second one is here, write a function that takes a file name as an argument and returns a dict. And so here, obviously, we're not going to be modifying what we got. In any event, we can't modify what we got because we got a string, and strings are immutable. It's going to return a dict. It's going to be the numbers. So the keys are going to be numbers indicating word lengths, and the values will be integers. How many words in the file have that length? Hopefully, I guess I didn't write it very clearly, but that's the idea. So here's what I'm going to do. I'm going to say here, def file word lengths. What a clever function name. Yeah, I know. And I'll say here file name. Once again, I'm going to say output equals dictionary. And I'm going to say here return output. Jonathan, I see that like you raise your hand. You can just write in the chat if you want, or if you just like bumped it accidentally, that's also okay. I will forgive you. So then what? Well, now we want to open up the file name. We want to open it and get a file-like object and be able to go through it. So I'm going to say here for one line in open file name. Now I'm getting the file line by line. But I don't care about the lines, I care about the words. So now I can take that line, break it up with split, and iterate over it word by word for one word in in one line split. So I'm taking the file name, the string here, I'm iterating over the file line by line. I'm then taking that line and iterating over it word by word. And now what can I do? Now I can say here, well, I want to get the length of the word. And I can say here, let's do, word length equals len of one word. And now I can do our standard like if word length in output, then we'll say here output of word length plus equal 1. Otherwise, output of word length, equals 1. Meaning, if this is the first time, so first time encountering this word length, so we're just going to assign to the dictionary this word length, the key is the length, the integer, and the value will be 1. But if this is not the first time, so add 1 to the count. And now, oops, didn't mean to erase that. And now that we got our function, now I can run it. So let's do a file word lengths, oops, on, oh, I don't know. Here, let me grab one of the chapters from my book or something. That has words in it. Where is it here? Manuscript. Got to do something with this thing. All right. So let's see. Let's grab this here. And then I'll do here. Let's do 3list.doc. I run that, and look what we get here. We get here a nice dictionary showing us how often every word length appeared. And don't worry, I really don't have 29 letter words anywhere in there. I'm guessing, I don't know what's going on there, 687 word. All right, I'm guessing that this might be from some code or something else that's going on. It's not necessarily an exact count here, but it's not a bad start. And it shows you, I hope, how you can have a function that gives us some functionality, and then you can imagine going at a higher level. And then I could say like file word or directory word lengths. And what I can do is give it a directory name, and then the directory word lengths function will go one by one through each of the files in that directory. So you can then use this as the sort of low-level infrastructure to build up higher-level functionality. And that's what we're constantly doing. Questions about this? Okay. So, last one. Write function takes 3 arguments, a list of numbers and 2 strings. So the 2 string arguments are the names of output files. The function will iterate over the list, writing all the even numbers in the first file and all the odd numbers in the second file. Function doesn't have to return anything. And by the way, when we say in Python a function doesn't have to return anything, the implication, well, we're saying here it doesn't have to use the explicit word return, but it will return something. It'll return the none value, and none is like this weirdo value that basically says there's nothing to look at here. So how are we going to do this? We're going to say here, I really should have given you the names of the functions, but fine, we'll deal. Def, let's say, even, odd, writer. And I'm going to say here, numbers. That's going to be my list of numbers. And I'm going to call this the, let's see, even file name and the odd file name. So now what? So now, well, I'm going to need to iterate over our list of numbers. I'm also going to then need to make a test. Right, so I can say like for one number in numbers, if one number modulo 2 equals 1, right, then it's an odd number, right? Remainder from dividing by 2 is 1. So if we get a 1 back here, I want to write it into the even file. I'm sorry, the odd file, right? So I'm going to do something like odd file write, and then we can do here something like one number new line. And this, why am I using an F string here? Because if I have to give it a string, I have to give write a string. And by the way, I know I haven't defined odd file yet. No, I see that Mal is already saying odd file name. No. I purposely, I'm using odd file. We have to do a translation between the file name and the file. We'll get there in just a moment. So I need to give odd write a string or write a string. So I'm creating a string here with an F string with a number in it and then a new line. And I can say here else even file.write of one number \n. So there is a problem here. And the problem is basically I've just used variables that don't exist. Why am I doing that? Because there's a difference between the file name, which is a string, and the file object to which we can actually write things. So let's do that. And what we're going to do is we're going to use with. I'm going to say here with open, and we're going to say here, I don't know, even file.txt for writing as, oh, what am I doing? Even file name. If they give it to me, all right, that's the dumb part. Even file name for writing as even file, comma, open odd file name for writing as odd file. And I just indent all that. So now what's going on? Now it's amazing, right? Now we run our function. We have our numbers. We have our even file name. We have our odd file name. The first thing we do is we open both of these files. So we use the even file name and open it for writing. And then we open the odd file name for writing. And now we have two file-like objects to which we can write. And then I just am going to iterate over the numbers. I'm going to either write to the odd file or to the even file. Let's see how this works. Even, odd, writer. I'm going to say here, 10, 11, 12, 13, 14, 15, 200, 203, 301, 308. Okay, I think that's enough. And we'll say here, even numbers.txt and odd numbers.txt. Now, these files don't exist yet, but that's okay, because when we open a file for writing, it exists right away for writing, and if it existed before, it does. Now we've emptied out whatever it had. So I run this, okay, silence, that's good, no errors. Cat even numbers, txt, look at those even numbers. Cat odd numbers, oh, I even did like, odd number txt, and there we go. So it seems to have worked. Pretty snazzy, huh? Questions, comments, thoughts about any of this? So this is how we can use functions. We come with some functionality that we can encapsulate with a name and with arguments, and then we wrap it up, and then if all goes well, we never think about it again. We never think about the implementation again. We can build on top of that function. And so you're just going to build and build and build more and more and more functions. Or if there's a problem, you go back and then you modify that function. We often talk about functions as black boxes, right? We can't see through the walls of them. We don't know what's going on. But in a language like Python, actually, we can call them glass boxes, right? Where we can actually see in. I can take any function I want and look at its source code, because Python is open source, because it encourages that, because it's not compiled, all these different things that I can see exactly how a function is defined, and then grab its functionality and then decide, is this good, is this bad, what do I want to change? Okay. Is this the end of functions? Of course not. Of course not. You can spend lots more time talking about functions. There are other additional kinds of arguments that we didn't talk about. There are techniques for working with functions that you can deal with. Really, functions are one of the biggest, deepest, most important topics in programming, because they allow us, well, all the things that I've talked about over the last few weeks. So let's now switch gears a little bit and talk about today's topic, which is modules. But I want to go back for a few moments and think about some things that we've talked about in past sessions. So I keep talking about the dry rule, right? Don't repeat yourself. And the idea is that if I have code that repeats itself in multiple places in my program, bad news. And we've seen two examples of this so far. We've seen, one example is, repeated code, or repeated or almost repeated code. And then we can replace it with a loop. So instead of saying print 1, print 2, print 3, print 4, print 5, I can just do a loop from 1 to 5 and print each of those numbers. So we can dry up our code, as it's called, using a loop. The other thing we saw, and we saw this just here, is code, or functionality, that exists in several places in a program. Write a function, and then we can wrap up that functionality. And instead of copying that code again and again and again, we can just call that function wherever we want. And yeah, it's good in all senses. It's easier for us to maintain, easier for us to think about. And believe me, if and when you find a bug in that functionality, better to have it in a function that you can change it in one place. But what if you have functionality that exists in several different programs. That is a similar problem, but we can't solve it in the same way. And the reason is basically that a function exists in one program. It exists in one file. So how can we deal with this? Now, programmers have been doing this for decades already. And the way that they typically deal with it is they will write a function, and instead of having it directly in the program, they will have it instead in a library. So we can have a library of functions, right? Commonly used by many different programs. And libraries are just like one of the most common things, starting with, let's say, at your company, at your organization, there's a certain protocol, network protocol for accessing systems. There's a certain way to access the file system. There's a certain testing thing. You're just going to have that in a library that you can use. But it can also be for commercial stuff. So let's say you're using a certain, or even not commercial, like open source stuff. Let's say you're using a certain kind of database. You want to access that database. So you can use a library that was written specifically to talk to that database and makes your life easier. Or if there is no library and you write one, then you're going to make it available to not only yourself, but other people, because boy, oh boy, it's such a pain to write such a thing. And so libraries are super, super common. And one of the things that they talk about in programming languages when you learn a new language is, well, what's included in the library? And it's standard library. And we'll get to that in a bit, talking about Python and its standard library and what's included there. So in Python has modules. And modules are basically the Python version of libraries. We typically don't call them libraries, we call them modules, but it's the same thing. Except modules actually do a little bit more. So modules are libraries of reusable code. But the other thing is modules provide us with namespaces. And namespaces are also a really important idea that in many languages are completely separate from the idea of libraries. In Python, they are one and the same. So if you have a library, it's automatically going to give you a namespace and vice versa. What is a namespace? The easiest way to understand a namespace is its last names, surnames for variables. So let's just say that I am collaborating on a program, heaven forbid, right? Collaborating on a program with someone else. And I write a file and they write a file. We're going to have our files work together. We'll talk about how we can do that in a bit. And I decide for foolish reasons to use the variable x. And they decide for their own foolish reasons to use the variable x. What's going to happen? Our x's are going to conflict with one another, right? That's what's known as a namespace collision. A namespace collision means two variables were defined in two separate places, and then because they're the same name, they clash. This happens if you're in a room and you have a relatively common name, and someone calls out your name, and they don't mean you, they mean someone else. Quick anecdote, when I first moved to Israel, so growing up in the US, not that many people had the name Reuven. It's like not unknown, but it's not that common. I get to Israel, I install a phone line, I decide to check to make sure it's working. I call the information line, and I say, I'd like the number of Reuven Lerner, please. And they say, which one? All right, so like there are more people in Israel with my name than there were in the US, what can I say? So having a last name avoids these sorts of namespace collisions in real life, and having modules avoids those sorts of problems in our programs. So if everyone's work is siloed off in their own module, in their own file, then we don't have to worry about those sorts of collisions. So let's start off with talking about how do we use modules. So we actually had one or two examples in this course of using modules. So I use a module by importing it. So I can say, for example, import OS. And this means I want to use the OS module. And that stands for operating system, files and directories. What did I just do when I said import OS? Notice it's not a function. No parentheses there. OS is not a string. It's not a name of a file I want to open. Rather, this is telling Python, go search where you search, and we'll see where that is in a moment. Go search where you search for new modules and find me the module OS. And then I want you to load it into memory, and I want you to make all of its functionality available to me. Well, how is its functionality available to me? Through the name OS. We're basically defining a new variable OS here. And that new variable is the gateway to finding all the functionality. So now if I want to, I can say os.listdir. And if I say listdir dot, so this means, dot means current directory. And there we go. Look at that. I have now gotten a list of all the files in the current directory. Not too shabby. And it's a list of strings. And we'll get back to this later, but you can imagine that we can iterate over it, right? Let's say this. What if I say os.sep, or sorry, it's not a function, slash. What the heck is that? So on Unix machines, os.sep is slash. But on Windows, it's, and you have to put a double backslash, it's a backslash. Why? It's the separator between names in a path from your file system all the way down to like also the directories, folders, and then files. So Python adjusts these values depending on what operating system is being used. So how can I find out what's in this OS module once I've loaded it? I can use the help function, help on OS. And this means show me the documentation, really the doc string, which you might remember from last time for functions, for this module. And let me tell you, it's going to be a lot of reading, so I hope you're sleepy. Basically, or maybe hope you're not sleepy. Basically, OS routines for NT or POSIX, depending on what system we're on. And so this goes through all of the different functions and all of the different variables and all the different functionality that it has here in the OS module. It is a huge, huge module, but you can imagine that makes sense because dealing with functions, dealing with files and dealing with directories is a really common thing we're going to want to do day to day in running our programs. And so it just like goes on and on. We are not going to look at all these things. I promise you that. But you're definitely going to want to use the OS module at some point. And so this allows you not to worry about it, right? How would you go about getting a list of files in a directory if you didn't have this? Oh my God, like that would be incredibly difficult. So they've provided for us right away. Now let's actually go back for a moment. Now I'm going to take this not even odd writer. So file word lengths, we looked at this before, and this takes one file name and it produces a dictionary for each file. I'm going to do something a little bit advanced here, but I think you're ready for it. If I want to, I can say, of course, file word lengths on a given file name. And it's going to give me a dictionary. What if I do this? What if I say here, for one file name in os.listdir dot. And then I'm going to say here, right, lengths equals file word lengths of one file name. What's it going to do? It's going to run this function on each file name in our directory and going to put it in a dictionary. So we're going to get a dictionary back and then another dictionary back, another dictionary back. But there's a problem here because, lengths, it's going to keep getting overwritten. Well, what would I like to do? I'd like to keep track of the lengths for each of the file names. Watch what I'm going to do here. I'm going to say here, lengths is actually a dictionary. And then I'm going to say lengths of one file name equals file word lengths of one file name. What am I doing here? I'm creating a dictionary, zeroing it out, right? It's new. And I say, let's go through one file name in os.listdir dot. So we're going to go through each file name in the current directory. We are then going to run our file word lengths function on each file in the directory, and we're going to assign it back into this dictionary, which means we're going to have a dictionary whose keys are file names and whose values are dictionaries, where we've created a two-level dictionary. Now, this is not going to work. We're going to get an error. And the error is going to be because it's going to give us all sorts of problems here in trying to read from the file. So I'm going to add a little caveat in here. I'm going to say we're only interested in those files that end with .txt. So I'm going to say here, if one file name ends with .txt, then we'll do that. And this will reduce the errors. And there we go. And now if I look at lengths, it's going to be kind of ugly. But we have here odd nums txt, the number of times, as1len.txt. Okay, that's going to be a long one. And we've now successfully created a dictionary of dictionaries just with these 3 lines of code. Thanks to the function that we wrote before, and thanks to os.listdir, which provides us with functionality, allowed us to compress our code down so we can think at a higher level. All right, this is the sort of stuff that you can do once you have these modules available. And part of the trick is knowing what modules are there and what functionality they provide. And that is a hard problem to solve because it takes time and it's frustrating. I'll show you a list. We'll go over it a little bit, but at the same time, you must realize it's going to take a long time to just learn sort of what is where, and you will find yourself reinventing the wheel multiple times until either you discover, possibly years later, that there's a module that does what you wanted, or at a code review session or talking to a friend or at a conference or something like that, oh my God, someone's already done what I did. And I think I mentioned before Larry Wall's statement about how good programmers are lazy. Modules are a way for us to be lazy. They're a way for us to avoid work, use someone else's effort, take advantage of it, and write code, only the new code, the different code that will actually help us with our work and not necessarily reinvent the wheel there. So this is one example of how we can not only use a function in a module, but integrate into something we've already done and thus get interesting results back. All right, questions or comments at this point about anything? Ooh, quiet day, quiet day. Stunned silence. All right. Okay. So let's move forward a little bit here. So what else can I get? Like what else? What are some other typical modules we're going to want? Well, I mentioned before that when we use import, Python looks around to see if a module exists with this name. So where does it look? We're going to need another module for that. So the sys module is where, Python's, I don't know, the Python environment is defined. So I'm going to say here import sys. Now, it might seem weird. How is the Python environment defined in something that was not loaded yet? Right? Like, how could that be? And the answer is it was loaded already. But the variable sys, the module sys, was not defined. So we didn't actually load anything new into memory. Rather, we now have this available to us. So I can say, for example, sys.version. What version of Python am I using? And look, I'm using 3.8.3. I'm so proud that I'm using 3.8 now. What can I say? I can also say, right, sys.path. Sys.path is a list of strings. And so when I say import ABCDE, Python is going to look for, so Python will look for abcde.py in all directories in sys.path. How does it do that? A for loop. It's going to do a for loop over this list. And so it's going to look here. Do we find abcde.py? We did not. Do we find it here? No. Find it here? No. Find it here? No. Find it here? No. Can't find it in any of these places. So you know what it's going to say? Module not found error. It did not find that module. I could have predicted that. Right? So basically, the sys.path variable defines where Python's going to look. And indeed, when we do load something, so for example, if I say OS, and I say, hey, where was OS loaded from? Python will tell me, oh, it was loaded from here. And we can see that user, local, seller, Python 3.8, 3.8, all this stuff, it is in there actually. Right? It's right here, I think, is that directory. I'll also mention, you can notice here in syspath, this is not a directory, this is a zip file. And that zip file contains all the modules that come standardly with Python. That just makes them easier to find. So you can, if you want, put things in a zip file also, and then they'll be found in there. So what other sorts of modules are available? Truth be told, a ton of them. So I'm going to go now to python.org. And I'm going to go to documentation. And we're going to go to docs. And then I'm going to look here for the Python docs, I guess. Not sure where it would be here. Okay, here we go. Library reference. So when you download and install Python, you get what's known as the Python Standard Library. And the Python Standard Library basically means this is the set of modules that come with Python that you don't need to download, you don't need to install, you don't need to do anything special. They are there, they are available. You do need to import them. Why? Because if all these things were automatically imported right away, Python would be even huger than it is now. And you don't need, why load all these data structures and functions into Python if you don't need them? So what modules are there? What exists? And I will also preface this by saying that the Python Standard Library is known to be huge and very rich. So it's very deep and good at everything. At the same time, it's very hard for people to know the whole thing. I would even say it's impossible for people to know the whole thing. So you will, over time, learn more and more of it. But there was a survey, I don't know, a year or two, maybe 3 ago, probably a year or 2 ago, in which people were asked, like prominent Python programmers sort of filled out a survey, how much of the Python standard library do they know? And the numbers went from, I don't know, 40% to 70%. And people even wrote, I have to look up the documentation for things that I wrote myself. It's so incredibly massive. So we have the built-in stuff that we don't have to load, that we don't have to import. But then we have text processing services. We have regular expressions. We can find the deltas, the differences between files. We can prepare strings for use on the internet. We can get input from the user with a really rich command line interface. We can use binary data. We can use data like dates and times and calendars. There are all sorts of collections we can use. Numeric data, functional programming, which is a pretty sophisticated technique. File and directory access. So if you thought OS wasn't enough, there's even more here you can do. For example, we'll talk about globbing in a moment. We can use that. Data persistence. So if you want to store things from your program. Compression, archiving, different file formats like CSV, cryptography, operating system services, running things in parallel, right? Networking, internet data, structured markup for HTML and HTML, XML. If you don't know what those are, you're a lucky person. Internet protocols, multimedia services, and then you have all these development tools that help with the actual creation and development of Python itself. Amazing, amazing, amazing stuff. And so the Python standard library is the same across all platforms. So if I write a program using my Mac and I give it to you on Windows, assuming I didn't use anything in the standard library that says explicitly, this will not work on Windows, it should work. And it's a bug for it not to work. And that makes Python really powerfully cross-platform also. So I mentioned that there's some other modules here. Let's look at one other example that I even just mentioned. So what I did here in my little example was I wanted to find all the files that end with .txt. And I did it by getting all the file names in the current directory and then filtering out the ones that don't end with txt. If you've ever done any work with files before, that's kind of annoying and that's kind of silly. Wouldn't it be nice just to say, well, I want to do a lister of like star.txt, right? Save myself a little if statement. That would be fantastic, but it won't work. It cannot find that directory. It's taking us literally. Where's the directory star.txt? I've never seen such a thing. What we need is a pattern. And if you've ever used the command line, you know the pattern allows you to say something like star.txt. And many people believe that that's actually a regular expression, a type of pattern you can use to understand, sort of interpret text. It's not a regular expression. This is actually a pattern language. So pattern language in the shell. And this is both Unix and Windows, more or less. They're each a little different. It's called globbing. I kid you not, I did not make this up. I wish I could make these things up. So what we're going to do is instead, we're going to say here, import glob. This means load the glob module into memory, making its functions available to us. How are its functions available? I'm going to say glob.function name. So if there's a function defined in the glob module, I'm going to do a glob.function name. Guess what the function is called inside of glob? That's right, glob.glob. It's the glob function in the glob module. I sometimes feel like someone's drowning in glob, blah, 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 blah. Okay, anyway. So if I do this, glob.glob will actually take this pattern and look for all the files in the current directory that match this pattern. And now we're going to get no errors. And if I look at it now, length is going to be, looks like the same thing. So basically, this allowed me to not deal with that if statement, not have to filter things in or filter things out. Glob.glob will do that work for me. And believe me, the patterns I can deal with are very, very sophisticated. So by knowing how to navigate through the standard library, we're doing a great job. But let me just point out one more thing with modules. I say here glob.glob. And can I just say glob? Can I just run the function glob? No, because glob is a module. You can't do that. And this happens a lot, that I say import to some module, and I want to use a function of that module again and again and again. Here's an example that I think we saw a number of weeks ago. I'm going to say import random. I say random.randint from 0 to 100. So this means return a random int from 0 to 100. And that works, and I got it back. But if I'm going to be calling lots of random numbers, it sounds like I'm making crank phone calls. If I'm going to be calling lots of random numbers here, it gets to be kind of annoying to say random.randint, random.randint, random.indent. And so here, I'd rather just say randint. Can I do that? Randint from 0 to 100? No, this won't work. Why won't it work? because it'll only work within the namespace. Randint is a function in the random module. It's not just floating around here in Python. You need to use its namespace. You need to use its module name. But there's a way around that. And I'll get to Larry's question. So basically, we can load or we can define a variable referring to a name in a module with from import. That's how this is or this is how it looks. I say from random import randint. What this does is it says, listen, Python, I want to have a variable, randint, not under the random namespace. I want to have it in the current namespace right here where I am. And so go into the random module, load it up, find the thing that is randint, and define it in my namespace as well. And from that moment on, I can say randint from 0 to 100. This is extraordinarily common. And I should add that it's extremely uncommon, extremely unusual to have a Python program that does not import any modules. Almost every Python program imports some modules. Probably not random right away, right? But it could be OS, it could be sys, it could be all sorts of different things. And if it's going to be repeatedly loaded things, repeatedly used things, it's often going to be from import. Larry asked the question, what is the difference between regex and glob? So basically, regex and glob works like this. Regular expressions are a complete pattern language describing all text. And it uses all sorts of funny characters to do that. It'll use like dot and star and question mark and so on and so forth. So those are regular expressions, aka regex, aka regex. Globbing is what we call like a domain-specific language. So globbing is only for file names and directories. And basically, file names and directories like, so I can say like star.txt, or I can even say something like star dot, like, I think you can do this, like not ending in a tilde, something like that, right? So it's much more restricted in what it can do, but it's also very powerful for what it has to do. And they use many of the same characters like stars, but they have completely different meanings, unfortunately. Renzo, hey, I owe you email. Renzo, you are asking here, what's the best practice for loading modules? So could it also make it easier to read? So I can see how random takes longer to write. Could it make it easier to read and know it came from the random module? That is an excellent, excellent point, yes. So from import is something you can do if you're really going to be using it a lot. And people do that for sure. Also, if you can have modules inside of modules inside of modules, and then you don't want to say a.b.c.d, you just want to say d. So you can say from a.b.c, import d. I would say that's a more usual use case, but it's not the only use case. And so basically, yeah, so I would say it's not such a big deal, because also everyone's going to see at the top of your program what you're loading. There is one bad, dangerous thing that you don't want to do. And I see this all the time. It drives me bananas. From, I don't know, OS import star. Please never, ever do this. What does this mean? It says, hey, Python, I want to go into the OS module. And absolutely positively every name that's defined there, I want to define as a name, in a global variable in my program. This is so disastrously bad in so many ways. And yet people do it all the time, because they don't feel like they're suffering the consequences. The problem is basically there's a number of problems. Number one is you might end up then with names that collide. It's like saying, let's go into a big banquet hall with a lot of people, when we're allowed to be there all together, no social distancing. Excuse me. And let's say, okay, everyone's last names are gone. Now try to find who's where, right? That's kind of crazy. So this is a bad idea. It also, like, things could collide and you're losing all the semantic benefit of the modules. So I would definitely encourage you not to do this sort of thing, even though people do. Krishnendu asks how to load modules which are not built in. So far we've seen two types of modules. So there are built-in modules which we don't have to import. And those are like string, list, int, dict, and so forth. And then we have built-in, then we have modules that come with Python, known as the standard library. So we don't have to install them. No installation, but we do have to import them. Okay, those are the two that we've seen so far. And so we can really import tons of stuff. And for a long time, they said about Python that it was batteries included. What do they mean by that batteries included? They mean basically that you don't need to go out and do other things. It's like those toy commercials, right? Where they would say, fun toy, excellent toy, batteries not included at the end. So here you don't have to worry about going and installing other stuff. Whatever you need to do your work in Python is here in the standard library. But you know what? That's no longer as true as it used to be. Oh, Sloan asked a question here. If you wanted to import random and randn from random, can you combine them? Yes, excellent question. You can say from random, import randint, comma randn. And then I don't know, rand? I don't know what I don't know what other things are there. Let's see if I can say here random. Oh, rand range. Let's do that. There we go. All right. So now we've imported both of these names, and I can say here randint 0 to 100 and rand range. I think it's 0 to 100, but I'm not sure. Yeah, I think actually randint is just like rand range, but with one more from it. So there's one more place we can get stuff from, and that other place is known as PyPI, the Python Package Index. And basically, let's go look at it, pypi.org. And pypi.org is one of the most important resources for a Python developer to know about. So what we have here is 242,000 projects. Okay, we're not going to go through all of them, right? We don't quite have enough time for that. Even read them quickly, even though I speak quickly. So what does this mean? What are these projects? What are these packages? Well, you can think of, oh yes, thank you, Norman. I'll send that to everyone. Let me send this to everyone here, pypi.org. I actually didn't have that until just a few years ago. It's like very strange. And so you can imagine a module is one file. A package is a bunch of files together with some metadata associated with it, so we'll know like versioning and what it depends on and so forth. And then PyPI has, they call them projects, but they're really just those packages with some distribution information as well. So let's do this. I'm gonna throw caution to the wind. Here, I'm gonna find some modules here just from this list here. So let's see. I go to Auto Galaxy. The study of the galaxy's light structure dynamics at the heart of modern-day astrophysical research. PyAuto Galaxy makes it simple to model galaxies like this one. Oh, missing for now. Okay, well, I guess it'll be done soon. But if you've ever wanted to model your own galaxy, Python is making that possible for you. So this package is here on the PyPI website. How can I download it, install it, get it working on my computer? And by the way, I've never seen this before. I'm going to really hope that it works well. So here's what I'm going to do. I could go to the download files here, download this tar.gz and unpack it and everything, or I could go and download this wheel file as it's known and then install it. But why would I work so hard? Got to be kidding me. I'm going to use the pip program. And pip is short for Python installs packages. I'm going to open up a new terminal window. I'm just going to say here, pip install, what's it called? Auto Galaxy. Now, a few caveats about this. Pip for Python 3 is often called pip3 instead of pip. On my computer now, it's called pip. Second thing is you might not have permission to install things on your computer, depending on who installed your computer and everything. So now what is pip doing? It's going to PyPI. It's downloading that wheel file we saw. And there's a, wait a second, this Astro stuff needs additional things. So it knows what it's dependent on. It's going to download whatever we need in order to get things working. It looks like it's downloading the entire galaxy for crying out loud. All right. Scikit image. Are you kidding me? Oh my goodness. Okay. 2 minutes of downloads. Fine. I'll let this happen just because I'm curious to see what it happens. Now, while that's downloading, you can see that pip is actually, and here you can even copy it if you want. Pip is one of the essential tools in the Python programmer's toolbox. It is not a Python function. You do not run pip from within Python. You run pip from the command line. You run pip from your terminal. And then it will go and install things, and it'll install them where? In one of those directories that sys.path includes, which means that the next time, let's see if it's done. No, of course not. All right, still got a minute and a half to go. The next time that you start up Python and you say, import Auto Galaxy, it'll just work. It'll load that up there. Now, how do I know this is okay? I know it's crazy to think that there are bad people on the internet, but I've heard rumors that this is the case. And maybe, just maybe, some bad guy could be uploading bad software to PyPI. How do I know that it's good? And the answer is you don't. There's no guarantee here that anything is good or non-malicious. The odds are staggeringly in your favor from everything I've seen over the years. But if someone really wants to upload something malicious, they can. And people have, not very often at all. And so one of the things you want to do is sort of say, well, how reliable is this product? How reliable is this project? And that takes a little bit of sniffing around. So here, I'm going to look at the home page. Let's look at this home page, often on GitHub, which is a collaborative service for a lot of software. And we see here, wow, lots of stuff going on here, right? So someone committed just 7 minutes ago, 462 commits. How many people are there? Oh, I see they changed how this looks here. 2 contributors, Jamie and R. Hayes, all right? And so it's 100% in Python. So we see that these 2 guys have been working on it for a while. That's encouraging, right? Doesn't mean it's not malicious, but it's encouraging at least. So is this done yet? No, of course not, 20 seconds more. And so you want to see how many people have been working on it for how long. You cannot actually see how many times it's been downloaded. And that's because PyPI downloads, or from PyPI, people download such a colossally huge amount of data each month that like the caching necessary is huge, and they can't allow people to know how many times things have been downloaded. I know it sounds kind of crazy, but it's the case. All right, is this done yet? Oh, that's exactly, okay. You get the idea. Oh, it's got site that it's really it's downloading indeed the whole galaxy. Fine. One other thing to keep track of is when you do pip install, it does not automatically update. It will install a new version of something. So if I have version 1 and on the internet already, and on the internet on PyPI there's version 2, pip install will not update it. Let me just see if I can find something a little smaller that I can install. Oh, Scrapey. Scrapey is good. Scrapey new. All right, I'm going to stop this here. Yeah, pip install Scrapey new. Hopefully this will take less time. All right, it's downloading things. There we go. Ha ha ha. That was nice and fast, right? I should start with that. And so now, but we don't actually pip. Oh, for crying out loud. So now if I say, like, I think this is going to work. Python 3 import Scrapey. It thinks for what? There we go. There we go, loaded. If I say, hey, where were you loaded from? It might be from what we did. Nah, it's probably like slightly different, but it's still there. And so basically, you can import, and once you've imported it, you have access to all of its functions, all of its variables, all of its everything that they are providing to us and making this functionality available to us. So PyPI is massive, 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 massive. I mean, I remember when it hit 100,000 projects. I remember when it hit 200,000 projects. Like now, it's just like crazy out of control. How can you know where to even start? I'll give you an example that I like to show, right? So I want to read and write Excel from within Python. So I'm going to search for Excel here. Watch this. 2,416 projects are including Excel. Just to find something that works with Excel is going to be a career in and of itself. So, by the way, I use pandas. So what should I do? Well, recently there's a new one called Awesome Python, a new website. And Awesome Python is probably around maybe 2 years, 3 years at most. And Awesome Python is, as they say, a curated list of awesome Python frameworks, libraries, software, resources. Meaning that if you are interested in a particular topic, go first to Awesome Python and look under the topic you're interested in. And then it will show you, here, files. I assume it's going to be here. Files, no, it doesn't really show it. Let's see. Can we say here, oh, specific formats processing. Not the best headline maybe, but fine. Right, so for Office, if you want to work with Microsoft Office, here are a bunch of different libraries you can use on PyPI. Oh yeah, absolutely, absolutely, sorry. I will put that in the chat. All right. And so basically, Awesome Python is a good first place to look for what modules you want to use. They have looked at the ones that are the most popular, the most up-to-date, the most maintained. Because here's how it can work in open source. I come up with a brilliant new idea. I come up with an implementation, I put it on PyPI. I then walk away, right? What do I care? No one's paying me for it. It's all open source, it's all volunteer. And yes, 200,000 modules have been produced by people as volunteers. It's quite amazing, but it's true. So let's say now someone else wants to use the functionality that I've uploaded and I've walked away from. Do they really want to bet their entire company on a module that someone's not maintaining anymore? So the rule of open source is basically you want a large community. You want the more developers, the better. The more users, the better. The more conversations, the better. Because at the end of the day, the community is what's going to provide you with your support and with your help and with the guarantee that things work. Is it possible that a package written and maintained by one person is going to be amazing and maintained forever? It's definitely possible, but it's less likely than 2 people, 5 people, 10 people, whatever it is. Cool. Questions, comments about any of this stuff? Okay. Oh, it's a lot. It's a lot. Yeah. I mean, it's almost hard to know where to begin when you're dealing with PyPI. It's just so explosively huge. Because what will happen is you'll go here, like let's say, and let's ignore awesome Python for a moment, right? Let's say I'm putting together a new e-commerce site. So what am I going to want to do? Well, I'm probably going to want to have some like package tracking, right? So I can say like put in package here. And here we have like 10,000, I guess it's like Unix packages, right? Or Python. So let's say like UPS or FedEx. Right, and so here we have Python UPS shipping interface, UPS integration, UPS web service, validates street addresses with UPS. So many people have done this that it's hard to know even where to start. And this is where this is where awesome Python can really come into play. And by the way, you will quite possibly find a module or package that works, download, install it, use it, and then find out, oops, actually it's not as well maintained as we wanted, or it doesn't implement the functionality we want. And so I think it was Joel Spolsky who said years ago that free software is only free if your time has no value. And you will definitely have to spend time looking through these things and figuring out which one is right, which one is better. So awesome Python will save you some time in that sense. But there's no doubt that it like takes a while to sort of figure out how this stuff works. That said, the interface, the way that you use modules does not change. It's always going to be import or from import. There's actually one alternative version to that. I might as well show you that as well. So you might have heard that in the data science world. In data science, we all use NumPy. So I can, because I've installed it from PyPI, of course, I can say import NumPy. But no one does that. And no one does that because then I have to say NumPy this, NumPy this, NumPy this, NumPy this. But I also don't want to say from NumPy import star. So instead we say import NumPy as NP. And this imports the NumPy module, but aliases it to NP. So if I say, hey, what's NumPy? Python will say, I don't know. But if I say, what's NP? Oh, that's NumPy. And this allows you to use a shorter name or more standardized name if you want, or to avoid conflicting with names in your current system. So using modules is really important. We're not going to talk here about creating modules, writing modules, but let me give you a quick secret, which is modules are just files with Python programs in them. That's it. And typically a module will define some variables and some functions. And they're just making it easier to pass them around. It also means that if you're working with other people, that they can make their functionality available to you via modules. And there's even a version of PyPI that can work inside of a company so that people can get the system working with uploading and downloading and version tracking and so forth without having to expose the company's things to the big wide world. Okay. Any other questions about this? Modules are really important. As you can see, it's like they are sort of the next step up in terms of abstraction layers. Okay. So while people write questions, or if they don't, we are almost, believe it or not, at the end of this course. When I started it, I wasn't quite sure how many sessions it was going to be. And about, I don't know, 5-6 weeks ago, I sort of plotted out what I was going to do. We have now basically reached all the content I wanted to go over with you. But the course is not quite over. So first of all, I am going to put exercises in the forum for homework for this coming week. So you're not done with me yet. I will still torture you for the next few days. Next week's session will be 2 parts. Well, 3 parts. One will go over the homework assignment. Number 2, I'm going to give a little like, what next? Where do we go from here? In terms of learning Python, in terms of career options, in terms of what people expect. And the third thing we're going to do is open Q&A. If you have questions about Python, if you have questions about programming jobs, the industry, you name it, I will be delighted to answer them. So come prepared with questions. I mean, like, not too personal, right? I'm having problems in my marriage. Not the place for me to help you with it. But basically, whatever I can do to help, I will do. I would not be surprised if next time we go over time a little bit. If so, that's fine. And looking forward to it. So thank you, everyone, for another fun, fantastic session and another great week. Have a good weekend. Stay safe. Be in touch. Be on the forum. I will try to remember this week to put up the questions a little earlier. And I will see you all next week for our final grand finale session. Bring great questions. I'm really looking forward to them. And the video will be up within the next hour or so on the website. All right, guys, have a great weekend, and I will see you next week.